Okay, in part 5, our last part for section 3.1, we actually do some of the extra problems that don't fit into a category of what we've already done. Example 6 is asking us to think about inputs and outputs again. It says if f of x is equal to 3x plus a over 2x minus a. So notice that this one would have some domain issues because we have x in the denominator, but they're not asking us about that. It goes on to say, and that f of 0 is equal to 2. They're asking us to find the value for a. Well, the 0 is my input, that's my x's. The 2 is the output, that's what this should be equal to once I plug in the 0. So that's what we're going to do. We're going to set the output to 2. We're going to come in and replace all those x's with zeros and then figure out what a is. So the output's 2. Every place we have an x, we're plugging in 0, and we just need to solve this for a. So the things with the 3 times 0 is going to give us 0. So we're left with 8 in the numerator. 2 times 0 disappears. It's 0. We don't need to write it over negative a. Now we need to solve that. I'm going to cross multiply. So I'll get a negative 2a is equal to 8 times 1, which is 8. And then dividing out, we'll get a is equal to a negative 4. So we were able to find a by them giving me an input and an output. And we'll do this in the future. We'll need to find specific coefficients and so forth when we write equations of parabolas and polynomials and rational functions. So we definitely need this ability for the input and output in order to be able to find something. And then finally, we're going to wrap up with example 7. And example 7 is an application problem of a function. So example 7 says, the function p of a, which is an ugly function. I'm going to write it out. So 0.015 a squared minus 4.962 times a plus 290. Okay, so there's a function. It represents the population in millions of Americans in 2005 that are 8 years of age or older. Okay, so in other words, we're going to plug in an age. We're going to get out how many Americans are that age or older in the year 2005. Okay, so we have an input, we have an output. The very first thing it asks us to do in part A is identify the dependent and the independent variables. So we talked about this at the beginning of the section. The independent variable is the input. And in this case, the input value is A. And I know that for 2 reasons. It's the only letter on the right-hand side. It's also the one that's on the inside of the parentheses. That's what makes it the input. And in this case, what they're talking about is the age that we're looking at. So we're going to say that age or older. So age or older. I guess put that. Then the dependent variable is the one that's the output. And in this case, that's P. It's P of A, but we're going to say it's P. So that's the population of Americans. That are that age or older. So then they're trying to get us to get a feel for what they're talking about with these inputs and outputs. It asks us to evaluate P of 20 and then provide a verbal explanation of its meaning. So now we're going to come in and replace A with 20. Be very careful. You should just be able to plug and chug straight through on this on the calculator. So every place I have an A, I'm writing in a 20. And then plus the 290.580. So when you do that on your calculator, you should end up with 197.34. Well, let's provide an explanation of what's going on. So in 2005, there were 197.34 million Americans that were age 20 or why would you need that kind of information? Well, you might need that kind of information if you're talking about insurance rates, if you're talking about census and voting rights, all those kinds of things. You would need to know how many Americans are a specific age. And that wraps up section 3.1 for us. 3.2, we're going to talk about the graphs of